So today, this session we will discuss about media access control or MAC. So we are aware that this data link layer has a sublayer called as medium access control sublayer. So this MAC sublayer, we will see some protocols which operate in this MAC sublayer. So basically, link to link connection is the data link layer load. So two nodes which are interconnected by physical media, and you have frames in the data link layer, and it has this objective of framing, error control, flow control, and physical addressing. These are the roles. So here the broad classification of this medium access control or multiple access control. So morning I gave an example as to say how this the example of people asking doubts in the class. Say if two people simultaneously ask a doubt, there that either the teacher can select the student, or, and in most cases people out of courtesy, one person will back off, allow the other person to say it out. There are other people who just watch. Say if another person wants to ask a doubt, they will see, say if a doubt clearing session is in progress, a doubt by a person is being addressed, the second person stays quiet, and sometimes and as soon as that person one, the doubt sits down, probably stands up and asks the doubt, the second person can ask the doubt, like that. That's the way your common channel can be managed. So different protocols do exist. So something which is called as there are broad classification. One is the random access protocols. So random in the sense the information, the frames can be sent at any time. There is no definite time slot or anything like that. Random, the channel is accessed at random. Channel, I mean by the term channel I refer to the common shared media. It can be an Ethernet cable, it can be electromagnetic, that is unguided media, that is electromagnetic spectrum, anything. So it can be a cable, whatever, that could be a common media which is shared by different users. So different protocols exist. So random access protocols, and then there is control access where you have some of them are outdated, but still this token is still there. Reservation and polling is in some, you would have seen this example of polling in microprocessors, isn't it? Polling, the interrupts and polling, isn't it? Yeah. So controlled access protocol, similar approaches there in this controlled access protocol. There will be some master which does this coordination. So this is also, these are used in WANs and LANs. This is in LANs mostly. Token ring is still there and in some use. But then there is a channelization protocol, multiple access, frequency division multiple access, time division multiple access, and code division multiple access. That you find it in cellular networks. I will leave a slide about these things later on. Say multiplexing, I think I've shared a portion of the slides related to this. I mentioned that this is an extra topic, and I left a slide called as multiplexing earlier, I suppose. So it might be in the classroom, just have a look at it. So some of these multiplexing scheme, multiple access schemes, all are discussed, especially the something related to this telephony and cellular networks are discussed in those slides. You can deal with them there. We won't be discussing these topics here. We'll be discussing in detail CSMA CD and CSMA CA. Aloha we will mention, make a passing reference so as to give get an understanding about the other protocols, because Aloha historically it was the first protocol which it was one of the first protocols which dealt with this random access case. So each station can so everyone is equal in that in the random access protocol. All this, there is no master slave relation or primary secondary, nothing like that. You are say any person can transmit at any time. All students are equal, they can ask doubt at any time. But if two people simultaneously try to access the channel, what happens? There will be a contention. Contention means there is a dispute, or I am the first, like that. There is a contention for the channel, and say two people simultaneously ask it out, means their speech will get mixed up. So the problem is that either the frames will be destroyed or they will be corrupted. Either of these things can occur. So collision is a result of contention. So there will be some mechanism to resolve this contention, and some mechanisms, one of these mechanisms in random access protocol is Aloha, other one is carrier sense multiplexes. You call it a CSMA. And CSMA has two variants actually. Say carrier sense multiplexes in the sense that you will, carrier sense means you will try sense the channel whether anyone is transmitting or not. So there is a strategy where you can detect collisions and back off from transmitting, and also you have a strategy to avoid collisions totally. And CSMA CD, so CSMA has two variants. Over a course of period, this has evolved into two variants. CSMA CD. CSMA CD is usually used in Ethernet. Specifically, you can say older Ethernets, say 10 Mbps Ethernets, which you can call it as the traditional Ethernets. So now we speak of 100 Mbps, 1 gigabits Ethernets. We have different variants of this. But then CSMA CA, so you call this the CSMA CD, carrier sense multiplexes with collision detect. This particular method is part of this IEEE 802.3 specifications, and this carrier sense multiplexes with collision avoidance, that is mostly for wireless networks, wireless LANs, and you will find that in 802.11 that deals with this, all this Wi-Fi, all those things. So 802.11 is has this CSMA CA, that is for wireless LANs, and you can say this is for wired LANs. We'll see this cases with the specific Ethernet cases later on. For the present, you think it's like that. We'll elaborate on that later. So, and first we see Aloha. Aloha is a Hawaii word. It's so the people at the University of Hawaii, they invented this protocol. You can't, it's especially for the satellite channels. So satellite communication was Hawaii is an island which is situated far away from the US mainland. So they needed multiple stations had to communicate, share the common link, uplink. So they devised a protocol which is called as pure Aloha, which is the first one. Aloha means hello, it seems. It has different other meanings. So it has spiritual meanings as well in the Hawaiian culture. So you read about it. So anyway, this all stations can transmit. So there will be always chance at any time they can transmit. That is what. There can be a situation where this frames get overlapped. This is the timeline. So the x-axis is the time. So if they have data, they just send a frame. The collisions can occur. All the frames at that. So even if one bit of a frame overlaps with some other frame, your frame will get corrupted. It's collision. You won't say it is a near miss. You will say it is all miss. That is what, it's all lost. So all these, both the frames will lose their data. That is the situation. So they had a variant of Aloha which is called a slotted Aloha. Slotted Aloha, you say that you divided up the available time to transmit into slots, and any station can transmit only at the beginning of a time slot. So is that clear? Okay. At the beginning of a time slot only, any station can transmit. It can't transmit at any point. If it has data, it has to wait for the slot to begin, time slot to begin, and only then it can transmit. Clear? And so this will reduce the number of collisions. This will reduce the collisions, but it makes this thing, the channel, inefficient. So it can reduce the number of collisions because say if only if it has data, it will just hold back and only transmit at its slot. So but still the number of there would be collisions. So this was overcome in other variants of Aloha, and other variants of Aloha do exist, but we'll see another random access protocol, which is called as carrier sense multiplexes, which is a bit more evolved form of Aloha, and CSMA, carrier sense multiple access. So as the term indicates, there are multiple users and they are trying to access the common channel. Don't get bowled away by this diagram. This just when we explain this, it will be clear. Now say I have say A, B, C and D, and you say this is Ethernet cable. This is a LAN cable which connects all these media. Now this you are sending your time, this is your time axis, and this is the space, you can say distance, whatever you say, temporal arrangement, temporal scale, and this is a time scale. So so B is starting a transmission, starting a transmission at T1, and the energy from this transmission, the packets, the frame is traveling through, say the concept is that when you transmit a frame, all the it's a common channel. You are speaking in a class means everyone in the class will hear. That is what you are not speaking exclusively to the teacher, so everyone will hear, so all the terminals will hear. But say if the person is situated far away from this node B, it will hear only after a small time, a small finite time. So there is a delay. So so B transmits and its energy is the data frame propagates. To what node it transmits, that's not a matter right now. It is transmitting a frame, so it's shown as a delay, the blue line which you see, the blue path. So it's shown as a frame which is going, there is a delay. And what happens is that C decides after time T2, C decides that I will transmit. So after time T2, which is where T2 is greater than T1, say there is a small difference, between T1 and T2, C also transmits. So C sends this is the green path which you see in the background, that is the transmission by C. It is also sending out frames, but the collision occurs after, say, closer to C. You can say at a space closer to C. This is x-axis, this is space. You can say it is somewhere closer to C, a collision occurs. So there is a probability of collision. So every station in carrier sense multiple access will listen to the channel before sending. B listened to the channel and saw that there is no collision, no one is transmitting at its end. But after time T2, which is greater than T1, there is a transmission by C. So there is a chance for collision in carrier sense multiple access also. So this is the common region. So both the signals are existing in this region. So there is so this point the collision starts, say maybe you will say at time T3, which is in between T1 and T2. There is a collision. Not in between T1 and greater than T2, there is a collision. So this cannot eliminate this collision. CSMA can reduce the possibility of collision. So you will say, if you will watch the channel, if you will see whether no one else is asking a doubt, and you ask your doubt. But it can happen that you got up and started to ask, someone had a better reflex and they started asking. So there is a collision. There can be collision. That can be there. So there is some say the worst case. You can say that the maximum time. Say if you take the case of say node A, which is transmitting at time t1, it will take a time, say the tp, capital T subscript p, that is a propagation time through the network, propagation time through the LAN to reach the node B. That is the maximum time. And for B will know this thing only after time, say after a while also. A will get to know. So T, the max, this is the vulnerable time. So vulnerable time is this. In this duration there is possibility of collision. There is a possibility of collision in CSMA. That's what we call as vulnerable. The frame transmitted by, say, A is vulnerable in this, which is equal to the propagation time. So this is the worst case, the maximum length, the node which is situated farthest. So that will be at each of these points only. B will sense that A has transmitted, C senses that A has transmitted, D will sense only after the signal reaches here. It might be a small few microseconds, but that matters. We are talking of electrical communication, so it matters. So so carrier sense multiple access is not a very good way to do this. So but there are some ways in which say this CSMA does this work. In fact, CSMA was used in the earlier Ethernets. Usually this technique, which is called as one persistent was used in earlier Ethernets. What if for instance the B is the different approaches, there can be different approaches. One, if the channel is busy, what to do? So different approaches. One particular approach is the one persistent approach. One persistent approach is that it will just check whether the channel is busy or not. If it is not busy, it will transmit. It won't. So that is there can be collisions. So the CSM one persistent approach will bring about collision. There is a very high chance of collision in one persistent approach. Whereas in non-persistent approach, what it does is it will again observe the channel, check whether the channel is being used by some person. If it is not used, it will transmit. If it is being used, it will wait for a random duration. Now, say for instance, the random duration is selected differently by different nodes. Say node A might decide to wait for 2 milliseconds, node B might decide to wait for 1 milliseconds, like that. Node C might decide to wait for 3 milliseconds. It's chosen randomly, and after waiting for a random duration, it will again check the channel, and if it is someone will get an access. So that's how you resolve in non-persistent approach. In non-persistent approach, it is check the channel whether it is busy or not. If it is busy, wait for a random duration, and then again check whether the channel is, so each node will choose a random interval, random wait duration. It will back off from transmitting. It will wait for, so the correct term is it will back off and wait for random duration and then transmit. That is a and then again check the channel, and depending on the state, so it will transmit. So this is a bit more better, but it is a non-efficient. It's not a efficient way to do that. It's not an efficient way to do this on a network, because for instance there could be more idle times. Idle times could be there, so random. It's so that is not a very good way to use, but it is reducing the number of collisions as compared to one persistent. Then there is a p persistent approach. P persistent approach combines both these techniques, and it will improve this efficiency as well as reduce the number of collisions. So you will have to select something. I mentioned here that so this is the maximum propagation time. Maximum propagation time has to do with this. This is the maximum propagation time, TP, capital T subscript P. So if you have time slots, if your channel has time slots with a slot duration which is equal to or greater than the maximum propagation time, only then it is this p persistent approach is used. So the maximum propagation time, you can say the time required for a frame to propagate from node A to node D, which is the farthest node. So your time slot should be greater than or equal to the maximum propagation time, because that only then you could keep this thing working. You could have this thing p persistent approach in working. So the basic step is that it will observe the channel. So it will observe the channel, check whether it is idle or not. So that's what it does here. If it is checking the channel, check, if you say this is p persistent method, so it will check the channel whether it is idle or not. Channel is busy, true, it will be again waiting. The channel, if this channel is not busy, it will generate a random number. It will generate a random number in between 0 and 1. So you call this as R, and this random number R, which will be say it will send this frame with a probability p. So random number R which is less than or equal to p, there is a probability of transmission. So you will say this is with the probability p, and it will just send this frame, and what happens, it will check, say it will check whether, so it is checking here that whether the channel is idle or not, and then generating a random number and then transmitting the frame, and the random number is say less than or equal to p. It's probability p, it sends its frame. So it's a chance you send, and it will wait for the next time slot. So you have assigned the time slot, and beginning of the next time slot, it will wait for the next time slot, and if it can transmit the next frame or not. So it is waiting that for the next time slot. It will check whether the channel is busy or not. So if say line is busy, it will just back off. Line is busy, it will back off. It is it's something really common sense, like it's a random wait. It's a random wait strategy. So you'll just say, if there is a collision, CSMA doesn't know what to do if a collision occurs. It just knows that to back off. Collision എന്തായാലും എന്ത് ചെയ്യണമെന്നുള്ള കാര്യം CSMAക്ക് അറിയില്ല. Collision, it doesn't know what to do in the event of a collision, or it doesn't know how to avoid a collision. The basic CSMA doesn't know that. That is not built into the protocol. It will, if the line, it will just check whether line is busy or not. The line is busy, it will just back off. It will behave as though there is no collision. If it finds the line free and it has frames to send, it will just send it. And say the probability, it will just say there is a probability p for this value. So the random value is generated, and this we'll elaborate this particular thing more in Ethernet. So basic idea is that it's a random, and again it will wait for the next slot. Your slot is as big as the propagation time of this, maximum propagation time of this link. So it will just wait and then retransmit. So it will wait, and and again so CSMA doesn't know what to do in the event of collision. So it will just check whether the medium is free, and sends the frame, and if there is a collision, the frame is sent again. Now CSMA CD is used in one persistent approach is used in the traditional Ethernet I mentioned earlier. So this is a technique which is which we will revisit when we discuss Ethernet. For the present, you see that this is just avoid this is sensing the channel. Then there is the other technique which is called as CSMA CD, carrier sense collision detect, carrier sense multiple access with collision detect. That is, we mentioned that carrier sense multiple access methods, they have evolved into two, something which a technique which knows what to do in case of a collision detecting a collision, and other one is to avoid a collision, CSMA CA. We will see CSMA CD first. So we mentioned that it is for for wired LANs. CSMA CD is for wired LANs. So this is summarizing, I'll just say summarizing, we say that we are discussing medium access control, how to access a shared channel, and we discussed about Aloha, pure Aloha, where all the nodes all the stations will just transmit, and without watching whether anyone else is transmitting, there is high chance of collision. Slotted Aloha, the stations have to wait for the time slots to transmit. And then we came across carrier sense methods. So in carrier sense method, the basic idea is that the channel is monitored for the any transmission, and if there is transmission, three approaches can be there. One is one persistent approach, where there is nothing is done, it is just transmitting, it just almost like Aloha, one persistent. So there is high chance of collision. Then non-persistent method, where there is non-persistent method where you call as a random wait is there in non-persistent approach. Or P-persistent approach, the wait duration, you'll have the wait duration in terms of this P and Q. We'll see that's why I mentioned we'll elaborate it when we discuss Ethernet. Okay, for the present, just assume that there is it will transmit a frame and it will monitor the channel, and if the line is idle, it will again send the frame. If it is busy, it will say that there is collision has occurred. It will assume that there is some collision has occurred, and it will just back off. So this is the event of collision, it is sent again. We will just revisit this when we discuss Ethernet in detail. So here I see that there are 4 nodes, again the same thing. You are transmitting the first bit of A and C. We are taking these 2 nodes, node A and node C. So the node A is transmitting at time T1, node C is transmitting at T2. Now what happens is that the C detects the collision at time T3. C detects the collision at time T3 and it will back off. That is what the CSMA CD does, collision detect. Whereas node A is understanding that a collision has occurred at time T4. It gets to know that a collision occurred at time T4. So what happens? It will back off at time T4. It will back off from transmitting the frame. It will detect collision and then back off from transmission. So this is where the collision occurs. Collision occurs at at this point, but these 2 nodes get to know that at T4 and T3 respectively. Okay, so they are backing off. So this information has to propagate. So this is collision detect. So collision detect, say, as I mentioned, there is a probability, the random value R. So back off time is also expressed in terms of this random number. That is why say you have a frame to send. So you will say the K is the number of attempts. And say it will make n attempts, you can say like that, to send a frame. And the frame average transmission time. TFR is the frame average transmission time. Average means the average of these values, and the backup time is expressed in terms of this random number which you generate in the range 0 to 2k 2 raised to k minus 1. So it's expressed in terms of these. So what happens is that it has some data to send. It will say this is the attempt 0, and say you can make maximum 15 attempts, say something like that. So you have specified a limit. You cannot indefinitely make transmissions attempts. So and it applies one of these persistent methods, say either one persistent or non-persistent or p-persistent methods are applied to this, and and then it enters into a loop whether to check whether it is persistent methods will make sure that whether that is the transmission has occurred or not. If the transmission has occurred, you will go to the next step where it is a collision, done or collision. So that is there. The thing is that it will observe this. It is a dual thing. It will send as well as receive simultaneously, transmit and receive at the simultaneously, either on 2 ports or on 2 lines. You can say that 2 ports. It will send the frame and observe the channel on other port. That is what the transmit node will do. Say for instance, node A will send the frame and it will keep on monitoring the channel on another port. So in the event of a collision, it can sense this collision. When it senses a collision, it sends a jamming signal. It sends a jamming signal. You can say a unique signal indicating that a collision has occurred to all other nodes over the channel, telling that there is a collision that has occurred. You all withdraw from transmission, and then what happens? All of them will withdraw from transmission. Your k is incremented, and here it is checked whether and it will, all these nodes will withdraw from transmission for say a random time. R is chosen in this range, so you will wait for TB time. So R into TFR, the average frame time. So it will wait. So does it does make sense? Say I'll tell. Say I am myself, Adul, and maybe Sanjana. We 3 people are in a discussion, and I start to make a point. I start a discussion. What happens? And Adul will hold back. Okay, but it seems that say both of us simultaneously start to speak, means I'll wait, I'll hold back. That's what. So the other person also, the third person, Sanjana, gets to know that these 2 people are have tried to speak simultaneously, and then she also has to make a point. It's a very heated discussion, so she also holds back the making a point there. Same sense, but the wait duration is randomly so there is a random wait. So summarizing, I'll say that each node will wait for a random time before when it senses a collision, and it will also inform every other node that a collision has occurred. So Adul will signal, wait, let me speak, or there is a collision has occurred. So we are both simultaneously trying to talk. Then a collision has occurred at some time, and it will send a jamming signal, and on receiving this jamming signal, all the nodes will enter into a wait phase, and that wait phase is random. And again it will go back to this loop. The case increment, it will go back, it will try to retransmit that frame, and any of these persistent methods can be used, either one persistent or non-persistent. So method will be used to resolve this thing. So we'll revisit this particular discussion, and we'll add more details into this particular flow chart when we visit Ethernet. So we'll give Ethernet as a specific case of CSMA CD and see how that happens. Okay, so we'll visit Ethernet next day. We'll stop for the day and